Hi everyone, I'm Aishwarya Padmakumar and I'm here to present our position paper, Dialog as a Vehicle for Lifelong Learning. Most machine learning applications follow a pipeline that looks like this. We design a task, collect an initial label data set, train a model, and test it on held out data. But in the real world, we may encounter test distributions that are different from the training distributions, that change over time, or that require a different task definition from what we started out with. To adapt to this, we would need to collect a new labeled data set for the new test scenario. An alternative paradigm is lifelong learning, where the model is designed to be initially trained on an initial labeled data set, and then as it goes through test phases, it collects additional labeled data for the same or different tasks, and the model is trained to incorporate these. Lifelong learning can make models more generalizable and versatile, adapting to concepts and tasks that are not predefined during the initial training phase. Lifelong learning is particularly relevant for robotics applications in environments such as homes and offices, where it may be difficult to enumerate ahead of time the objects the robot may encounter or the tasks it has to perform. In this position paper, we present Dialog for supporting lifelong learning as a new challenge area for Dialog researchers. Dialog systems are in a unique position to perform lifelong learning, as by design they interact with users at test time. This provides a mechanism for collecting additional label data during operation. To do this, Dialog systems would need to incorporate active learning, identifying examples that are most likely to improve the model and querying for their labels as part of the dialogue. One framework for doing this is opportunistic active learning that incorporates locally convenient active learning queries into dialogues. These queries may not improve the performance of the current dialogue, but are designed to improve the expected performance of future interactions. An example would be a robot, when asked to bring a blue mug, may point to an object nearby and ask whether the label blue applies to it. The robot may also query for a different label that is such as tall that is not related to the current task, if that is more likely to be helpful in future interactions. We believe that this area presents a number of interesting challenge problems for dialogue researchers, including designing dialogue acts to collect new types of labeled examples. For example, a robot engaged in a cooking task may ask how a particular step, such as opening a can, can be performed in a different way, expecting a demonstration. Another challenge is collecting data sets and designing dialogue simulations to demonstrate new concepts being added at test time and providing correct answers to active learning queries. Another challenge area is prosodic analysis to identify emotions such as urgency, stress, sarcasm, and frustration to determine when it is appropriate to query for active learning. To learn more, please take a look at our paper or contact us with your questions.